If you do it right now, you're going to miss probability.
I'm gonna send you the picture right now.
Okay, wait till after class, Matthew. Okay, let's take a look at the probability problems. What did you guys think of those? Okay, probability is something that we, the last piece that we need to cover.
I would say that you have to get used to it. For some of the things, like for the two-part type of ones, you have to like learn like how, if you need to subtract or like multiply them. So.
That's true. True. Yes. Okay. Well, let's look at number 1 first. Number 1, you roll a single die numbered from 1 to 6. What is the probability of rolling an odd number expressed as a fraction? And we kind of talked about that one just like that. So Nathan, what did you put for that first one?
1/2, like 1/2.
Very good. 1/2. Good. There's 6 total outcomes, and 3 of them would be odd. So 3 over 6 equals 1/2. He expressed it just as they said, as a fraction, right? We could say 50%. We could say 0.5. We could say 1/2. And they said as a fraction. So 1/2 it is. Good job. Okay. Number 2. A jar contains 12 caramels, 7 mints, and 16 dark chocolates. What is the probability of selecting a mint expressed as a fraction? Emma, what did you put for number 2?
I said 7/35 or 1/5.
Good. There's 7 of them that are outcomes that we want out of 35 possible, and she reduced that to 1/5. 7 out of 35 equals 1/5. Good. Okay. Number 3 was a little bit different in the way they asked the question. You have the numbers 4 through 14 placed in a bowl and drawn at random and then replaced after being drawn. Is it likely you'll draw a number less than 7, or is it unlikely? So if it's less than 50% or less than 1/2, it's unlikely. And if it's greater than 50%, it's likely. So we have the numbers 4 through 14. Is it likely that we will pull one that is less than 7? Okay. Matthew, what did you say for number 3?
I said unlikely.
Correct. Unlikely. How many outcomes, favorable outcomes, are there, Matthew? How many outcomes that we want? A number less than 7.
I didn't write that down.
Oh, okay. Well, let's think about it. Less than 7, and it's from 4 to 14. So 4, 5, and 6 are outcomes we want. So we have 3 things we want to happen. How many possible? So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have a 3 out of 14 chance of picking something less than 7. They didn't ask, so you didn't have to put that fraction down, Matthew. You just had to say unlikely. But I just want to show why it's unlikely. 3 out of 14 is less than 1/2, a lot less. So it's pretty unlikely. All right, let's look at number 4. In a deck of 52 playing cards, what is the probability of drawing a spade expressed as a decimal? Lauren, what did you say for number 4?
25%.
Good.
25.
Good. Yep, there are 13 spades in a deck of cards, and there's 52 total cards you could pull. So that's 13 over 52. And if you reduce that, it's 1/4. And they asked that you put it as a decimal. So Lauren said 0.25 for 1/4. Right. Good job on that one. Let's see. I know I didn't give you guys all of them, so I'm trying to see which ones I told you. I know I put it in your, that we didn't do 5 and 6,
7,
but we did 7.
9,
Yeah, we just skipped the odds ones. Okay, so 7. Number 7, Gavin, could you read that one for us? And Gavin, can you take off the picture of the pyramid and put you on it so I can see you in my class?
I think
Are
he
you
was
with me?
here at the beginning of class.
Are you with me, Gavin? Let me look here. Gavin. He's in Meet, but I don't know what happened to him. Okay. I'm going to go to Abby. Abby, would you read that one?
What number did he say?
We're on number 7.
Oh, I'm sorry. I forgot it was on the computer.
Okay. Are you okay?
Yeah. It's just I have very slow internet today because we had a storm yesterday,
Oh,
and
okay.
there's probably a storm coming today.
Okay. Do you want me to go on to somebody else, or do you got it, Abby?
I got it now.
You came up? Okay.
Yeah, it's coming up now. There's a jar of jelly beans with the following flavors: 12 are grape, 17 are blueberry, 5 are pineapple, and 13 are coconut. What is the probability expressed as a percent? Gosh. Selecting either a grape or blueberry, replacing it, and then a coconut or pineapple.
Okay, so this one was a little bit trickier, but it's okay. I wanted to see if you could do this, and then if not, I'll show you how to do it today. What did you get for your answer, Abby?
I did 50%, and I don't know what I did.
Okay.
Can I say what I got?
50%? Who said that?
Lauren.
Oh, Lauren, what did you get?
I got about 24%.
Okay, yep, it is going to be about 24%. And I'll show you guys why.
Or like 23 points.
There's 47 jelly beans total, okay? So if you do the first thing that it tells you, which is to select either grape or blueberry. So if you count up your grape or your blueberry, you get 29. And then if you put them back in, you'd still have 47. And then they said coconut or pineapple. There's 18 that are coconut or pineapple. When you have multiple probabilities, like one right after the other, you have to multiply them together. So you have a 29 out of 47 chance of the first thing happening. And then you put those back in. So you still have 47 in there. And the second thing happening, there's 18 jelly beans of that kind. So you just multiply straight across. 29 times 18, that would give you 522. 47 times 47, 2,209. And they wanted that as a percent. So you're going to type in your calculator 522 divided by 2,209. And you'll get like 0.236 something. And when you're rounding it to a percent, that's about 24%. Percents go to the hundredth, right? Percent means of 100. So to the nearest hundredth is 24%. So that's how you do one like that. Multiple probabilities. Just multiply your probabilities together. All right. So number 8, let's see. Karen, could you read number 8 for us? Do you have that up on your computer? Maybe I should share my screen. Let me share my screen because I have it on mine, and then you guys will be able to see it. I know
Okay.
Abby said she was having a hard time finding it, like getting it up on her computer. Okay, so let me present, and I'll pull it up on mine. Okay, my whole thing. Okay. Are you guys seeing my screen yet?
Yes.
Yes? Okay. Karen, can you see my screen?
Yes.
Okay, Karen, will you read number 8 for us?
So there are 29 students available to represent the upperclassmen at the fair. 13 are juniors and 16 are seniors. What is the probability as a percent that a senior and junior will be chosen?
That a senior and a junior will be chosen. Okay. So this is going to be, again, multiple probabilities. So what is the probability that a senior will be chosen? Well, that's 16 seniors out of 29 total. And then if we want a junior, I don't know if you guys noticed, if you had scrolled down, the answers were on there. But for the for the juniors, there are 13 juniors, but now there are only 28. Can you guys see my board if I'm sharing my screen though? So you're going to want to take 16 out of 29, okay? 16 seniors, 29 total kiddos. And then you're going to multiply it by 13 juniors, but now you only have 28 kids left because we already picked one of the seniors, okay? So you're going to take 16 over 29 and multiply that by 13 over 28, okay? So if that's not what you did, go ahead and get your calculator out and do that part now. 16 times 13. Okay. And 29 times 28. All right. And then let's see, what did Karen tell us they wanted expressed as? Expressed as a percent. Okay. So you'll express that as a percent. All right. Did you get that one, Karen?
Yes, I did.
You did? What did you get?
So for juniors, I got 44. So for juniors, I got 44.83, and for seniors, I got 55.17.
Okay, we want to put it together kind of and say, what is the chances that we're going to pick a senior and then a junior?
Mm-hmm.
Okay, so we're going to do, yeah, let me stop presenting for a sec. If I stop presenting, then maybe you guys could see my board. Okay, can you see my board now? Okay, so 16 out of 29. There we have 16 seniors and 29 total kids. We'll multiply it by picking a junior. We have 13 juniors and only 28 kids left because we already picked one of the seniors. Okay, and you'll multiply it straight across and get 208 over 812, which should be about 26%. Let me check our key. And yeah, about 26%. Okay. That was number 8. Okay, number 9. Let's share our screen again. And number 9, I'm going to see if, Gavin, are you with me again or no? Gavin? Okay. Nicholas Petrick, are you with me, bud?
Yep.
Oh, awesome. Hi, Nick. Okay. Number 9. Could you read number 9 once you can see my screen?
Mm-hmm. In a deck of 52 playing cards, what is the probability as a fraction of drawing a picture card, replacing it, and then drawing either a heart or a diamond?
Okay, so I'm not sure how you did it, but let's think about it now, Nicholas, okay? There's 52 cards total. That goes on the bottom, right?
Yep.
Probability of picking a picture card, an ace, a king, a queen, or a jack. So in a deck of cards, how many cards are an ace, king, queen, or jack?
16.
Okay, yeah, so there's 4 aces, 4 kings. Sorry, so we got 16 out of 52 that we're going to pick an ace, king, queen, or jack. Okay, we pick a card, that's 16 out of 52. We replace it. So because we're replacing it, we still have 52 cards for our next draw. How about drawing either a heart or a diamond? How many of the cards are hearts or diamonds, Nicholas?
26.
26, half of them. Good. Okay. So let me stop sharing so you can see my board. Oh, doesn't want to. Oh, no. I think I can do it over here. Okay. So Nicholas said we're going to do this probability. 16 over 52. 16 face cards and cards times 26 over 52. And straight across again, and then turn it into a percent. Okay, so I want you guys to work that one out right now. 16 times 26. What did you get for the top, Nathan? Nathan, are you with me? You might be muted.
For the top, so then I did 16 times 26, and I got...
Yeah, what did you get? Do you have your calculator handy?
No.
Well, you need to have it for class, okay? Because you're going to want to use your calculator for that. Lauren, what did you get when you multiplied that?
416.
Right, you have it, Nathan?
I said 416.
Yes, good. 416. That's it. Okay, Lauren, how about the bottom? 52 times 52. You're muted, Lauren.
Sorry. I got 24,004. Wait, 26,004?
I think it's 2704. Let me try it again.
Oh, yeah. Yep. Sorry.
Okay, so now we're going to take the 416 that Nathan said, divided by the 2704 that Lauren said, and our percent is what, Nicholas?
I said it was about like 15%.
Yep, good, because when we divide that, we get like 0.153, so that is about 15%.
For which number?
Number 9. Okay, we're going to move on to number 10. And I'm going to have Emma read this one. Let me just pull it up, Emma.
I have it.
Okay.
Number 10.
Yep.
Yeah. There are 12 men on the basketball team. 2 are centers, 5 are guards, the rest are forwards. What is the probability as a percent that out of the 2 players chosen at random, they would be a guard and a forward?
Okay. So let's do a guard first, okay, Emma? We're going to choose a guard. So what's that fraction look like?
Sorry. A guard. It's like 5 out of 15.
5 out of
sorry,
how many
I'm
men are on the basketball team?
Sorry, I'm thinking of 12.
Yeah.
Like 12 men, 2, 5. So,
5 out of 12, okay?
Yeah.
Okay.
Yes.
5 are guards, the rest are forwards. So we pick a guard first. That's 5 out of 12. And now we want to pick a forward. How many forwards are there?
7. Wait, no. 5.
Yeah, there's 5 guards, and the rest are forwards.
Yeah.
So how many forwards?
I'm like, sorry, I keep looking at a different one. Wait, if there's 5 guards, yeah. So there's 5 forwards.
Now, there's 5 guards, but there's 12 people total, 12 men on the team. 5 are guards, so the rest are forwards. So 12 minus 5.
7.
7. Okay, good. So we have 7 forwards. How many people are we picking out of?
Wait, we don't have 7
2
forwards,
center.
though.
Yeah.
Yeah,
There
there's
are 2.
Oh, sorry. Oh, I'm sorry. I didn't see the centers. Okay, sorry, Emma. I'm
It's
misreading it. Okay, sorry. 2 centers, 5 guards. The rest are forwards. You're right, 5. Okay, 5. And how many total people are they picking from?
12.
Okay, this time we're going to make it an 11 because they already picked
Oh,
one.
yeah.
Okay, remember they picked the first guy and they didn't put him back in. They picked the first one who was a guard. Okay, and then so that's 5 out of 12 that they would pick a guard, and then 5 out of 11 that they pick a forward. Okay, so we're going to do 5 out of 12 times 5 out of 11. And we multiply straight across. All right, so I want everyone to do that, and we'll figure out what the percent is. I think they want
got-
the percent.
What do we
Okay.
want?
Can I say what I
5
got wrong?
over 12 times 5 over
Wait, can I
11.
say-
Yeah, go ahead, Emma.
I got 25 over 132.
Yep. Okay, so turn that into a percent. So you're going to do that division. 25 divided by 132.
Yeah.
And what did you get, Emma?
I got like 19%.
Yep, approximately 19%. 0.18939. Okay. All right, let me take a look. So that was number 10. Which other ones did I give you?
12.
Number 12. All right, do we have time? Let me check our time. Oh, we do. Okay. 15 men on the roster of a baseball team. 2 are catchers, 6 are infielders, 4 are outfielders, and the remainder are pitchers. Okay. 2 catchers, 6 infielders, 4 outfielders, and must be 3 pitchers. What is the probability out of 2 players they would be a pitcher and an infielder? Okay. So, does everybody have that up for them, or do you need me to do the share screen? Does everyone have the paper? Matthew, do you have the paper in front of you?
No.
What is the thing you have in front of you?
Oh, that's my notebook.
No, the thing in your hand.
Oh, that's the wire to my headphones.
Oh, okay. All right. Try to put that down. And if at the same time as you're in my class, can you go to your Google Classroom and
Okay.
then look at the paper? Okay. So we have 15 men, and we want to know if we would choose a pitcher first. So we have to figure out how many pitchers there were. And I think there's 3 of them, unless I counted that wrong again. So 3 out of 15 that we choose a pitcher. And then an infielder, there are 6 of them. And we only have 14 men left after that. Okay. So 3 pitchers out of 15 times 6 infielders out of the 14 guys we got left. And they wanted to know, what is the probability it would be a pitcher and an infielder? Okay. So go ahead and do your math for that one. Did I ever get Abby back? Abby is back. Abby, are you with us? I know your connection is a little bit low. Okay. Nathan.
Sorry, my grandma.
That's
My
okay.
grandma called me. and tried to tell me
Nathan, what
to-
did you get for the top of this one? For the numerator? Did you unmute, Nathan?
I thought it was only 1 through 4, and 7 through 10.
Yeah, this one is number 12, but we're working on it now. Are you working on it with us? Remember, I held it up? Okay. Emma?
Can I say what I got for the top and bottom and then the percent?
Yeah, go ahead.
I got 18 out of 25, which is equal to 8%.
18 for the bottom. Did you, on the bottom, 15 times 14?
I must have typed it into my calculator wrong because my calculator's been acting up.
Okay.
Oh, yeah, sorry. It's 210.
Yeah, 18 over 210. That's approximately 9%.
Oh yeah, because my calculator's been acting up. Because whenever I type in a number, it like multiplies by 2 for some reason.
What would that what would the fraction be?
18 over 210. Okay, so what I want you guys to work on is a couple of things. I'm going to give you a few more problems. I'm going to give you on the same page, 13, 15. I'm going to give you. Okay, I'm going to give you 5 of these problems. Okay. I'm going to give you numbers 13, 15, 17, 19, and 21. Okay, so that's on the same sheet. But there's something else I want you to do. I want you to look something up. I want you to look up the difference between probability and odds. Because you probably saw that there are a lot of questions on there also about odds. And we skipped over that because there's a difference between finding the probability of something and finding the odds that it'll happen. Maybe some of you, if you're gamblers, you might know the difference. You might know what odds are. Okay, but I want you to look that up, and then we'll talk about the odds problems tomorrow. Finding the odds that something will happen. It's not hard. It's just a little bit different than probability. Okay.
Remember,
So
we
do 5 problems, and then find out and tell me what's the difference between probability and odds.
I just have a quick question, real quick, for
Yeah, go ahead.
everybody.
Yeah.
Do you guys have religion on your Google Calendar?
No, I don't think we're doing it until tomorrow because we're working on the thing for the
Yeah,
email.
we're only gonna have
Uh,
class. Well, not only gonna have class, but we're gonna
Yeah.
have class on Wednesday, so she can check on her
Well,
project.
yeah, and also for me, I don't have it for the rest of the month. For religion.
Yeah.
I'll email her about it.
Okay, yeah, I saw an email this morning that said 7th grade you should work on your project during our class time today.
Mm-hmm.
Oh yeah, I finished
Right,
mine.
So that's probably okay. Bye, guys.
Bye.
Have a good day.
Thanks, you too.
Thank you.